Okay, guys, for that, for D, your calculation is going to be exactly the same as mine. All right, so that is done. Maybe you can write it a little bit differently. If you're not sure of yours, you can always come show it to me and I'll tell you whether it's okay or not. They told us again, remember that the perimeter of this equilateral triangle was 105 millimeters. Right? They told us that the perimeter is 105. They didn't tell us what the lengths of the sides are. In order to get that area, we need to know what the base is, so this side, and we need to know what the perpendicular height is. Okay, so what I did there is I just wrote, I think yesterday we just said small x. That's fine if you wrote a small x, all right? So the side of the triangle is 105 divided by 3. Right, if this was a scalene triangle, right? Are we listening? If this was a scalene triangle, could I have done 105 divided by 3 to get the sides? No, all right. The only reason why I can divide the perimeter by 3 to get the length of the side is because all 3 sides are equal. All right, that's why I'm saying 105, the perimeter divided by 3. If they weren't equal, I couldn't have done it. All right, it would have had to give you some other information. So the length of the sides, all 3 of them, will be 35 millimeters. I'm just going to add here that this one here was also 35. Okay, we find the that step, getting the length of the side. Then guys, to get the perpendicular height, you would have to draw it in. Remember, this wasn't drawn in. And then we wrote on the side of the board yesterday that in an equilateral triangle, or even an isosceles triangle, right? Even if this side wasn't equal to those two, if those two sides are equal and you draw a perpendicular height, it will always cut the base, whatever that base is, in half. All right, so the base was 35. So this perpendicular height, when I draw it in, makes that part half of 35, which is 17 and a half. And that one also 17 and a half. If this side was, say, 40, that would be 20 and 20. All right, if it was 42, it would be 21 and 21. All right, it doesn't actually matter whether the base is equal to those two sides, as long as these two sides are equal, right? The sides that you're basically drawing that perpendicular height from, right? In between those two sides. If those two sides are equal, it will always cut the base in half. Okay, we did write it down there. So that is why I can now work with Pythagoras either in this triangle here or in that triangle. They are exactly the same two triangles, right? H is not the hypotenuse. So to calculate h, I'm going to say h squared is the hypotenuse squared minus the other side squared. Okay, so 35 squared minus that one squared. And your reason, please remember, guys, whenever you're using Pythagoras, you have to write Pythagoras. You type that into the calculator, you get 918,75. You then say square root answer, and you get your perpendicular height. Okay. Then, like I said, and I did ask you guys to do this calculation on your own. I just wrote on the board up until that point. You had to find the shaded area, which is the area of the circle minus the white area, right? Minus the area of the triangle. So the area of the circle, guys, they told us that the radius is 20. Okay, I didn't write it down here somewhere. It was written in words. They said this, the radius of the circle is 20. So for the area of a circle, what's that formula again? Pi times radius squared, right? That's the formula that I'm using there. So pi times 20 squared, they gave us that 20. Okay, it's just not on the picture, but they did tell us that the radius is 20. Minus the area of the triangle. Remember, the triangle is half base times perpendicular height. Okay, so that is, oh no, I made a mistake. What did I use here, guys? Did I use the whole base? No, I just used half of it, hey? So I was actually meant to write the 35 there, sorry. If you guys notice that I did something wrong, just tell me, hey? Half times 35 times that height. Half times 35 times 30,31. Sorry about that, guys. And then your final answer, let me just check quickly. minus. The final answer is then 726,21 millimeters squared. What's this?
Yeah,
It's not a bigger number because you're multiplying it by pi. Pi is like 3,147 something times 400. Okay, we're fine with that, right? Exactly. Like I said, if you get a question like this, the next exam, it will be like the difficult question. Okay. I don't stress about this one too much. What you do have to understand is that sometimes you must use Pythagoras, right? In a question where they might not tell you that you have to use Pythagoras. Okay, we will practice some more like that. And then also, you need to understand the whole concept of area of the bigger shape minus the area of the part that's been cut. Okay, that's basically what I want you have to take from this. And also, this is interesting that they can give you the perimeter and you must use that to find the sides, right? They might not always just give you the sides. They might give you other information that you must. Okay, all fine. So guys, for the next one, I just did the calculation in centimeters squared, so I'll do it quickly in millimeters squared as well. I'll do that with you guys. For number 2 there, it was that kind of shape. I think it was a picture frame. What were they talking about? Yes, a rectangular picture frame with outer dimensions 18.9 centimeters by 13.9. That was also filled in on the picture. And then they said inner dimensions 15 centimeters by 10. Guys, the inner dimensions were not filled in on the picture. Right, so you had to read what was written in order to see that the inner dimensions were 15 centimeters and 10 centimeters. So for this is the answer to B. All right, they wanted the answer in centimeters squared for B, and then for A they wanted millimeters squared, which I'll do now. All right, so the shaded area is the outer rectangle, 13.9 times 18.9, minus the inner rectangle, right, which is 15 times 10. See, that's not too bad, right? A rectangle minus another rectangle. For A, you had to change all of those measurements into, or all of those dimensions into millimeters, right? So I'm just going to write it here. You didn't have to write it like as a separate step, but 18.9 centimeters is how many millimeters? Okay. 189. Hey, how many millimeters are there in 1 centimeter? 10. Okay, so you will have to multiply that by 10 to get it. Then it's the same for all the others. 13.9 centimeters is going to be 139 millimeters. 15 centimeters, so these are now the outer dimensions, right? The inner dimensions, 15 centimeters is going to be 150 millimeters. And what was the other one? 10. 10 centimeters will be 100 millimeters. So now you have to do the exact same calculation, but just working with the millimeter dimension. All right, that was actually what you had to do in A, sorry. So here you're going to say shaded area. And you're obviously going to get a much bigger value. So it's going to be the outer rectangle. So it's 139 times 189 minus the inner rectangle, which is going to be 150 times 100. I'm going to see quickly what exactly that comes to. 11,271 millimeters squared. Okay, so that was actually the answer to A, guys, and that was the answer to B. Are we finding that conversion thing? As if they're asking you to leave your area answer with a unit that's different from what they gave us, right? So they gave us centimeter units. They were asking for millimeters squared for your area units. Do your conversion first before you find your area. Okay, don't do area and then try and convert afterwards. It's actually much more complicated that way. So first convert all your measurements to the one that they want. So if they're saying millimeters squared, first convert all of your measurements to millimeters and then calculate the area. Okay. Any questions on that one? And number 3 was very similar. The picture just looked a little bit different. Again, I think this is the answer to A. Okay, this is A's answer now. So for B, I'm just quickly going to do all of those conversions. It's the same thing, guys. Oh, no, it's not actually. Now we're doing meters squared. All right, so we'll chat about that now. The outer rectangle, 22 by 11. All right, 22 times 11. Then you're going to minus this small inner rectangle here, 9.7 times 5.6. Okay. Does anyone else get this answer for A? Okay, good. All right, for B, they're now saying we need to give our answers. Oh, and they're saying do not round off. Okay. We need to give our answer in meters squared. So we have values in centimeters. We're now not going to millimeters. That's quite an easy conversion. We now have to go to meters squared. Right? What is that relationship again? How many centimeters in 1 meter? 100, hey? 1 meter is equal to 100 centimeters. Okay, so let's start with the outer dimensions. 22 centimeters. What do you think? What's that going to be? It's going to be a 22 bigger or smaller than 100? Smaller. Hey, so it's going to have to be 0, something. All right? 0, what? 0, 22 meters. Okay, 11 centimeters. I'm just going to move a bit to the side. 11 centimeters. What's that going to be in meters? 0, 1 meters. Okay, now I'm going to do the inner ones. These ones are a little bit more difficult because they're much smaller than 100. But I'll show you now 9.7 centimeters. That's going to now say 0.97. No, because that will be 97, hey? So I'm going to have to say 0.097 meters. I think we'll practice some more conversions maybe tomorrow's lesson just to make sure everyone's on board. And I must just still print that note. I must just remember to print it for tomorrow. Then 5.6 centimeters is going to be 0.056 meters. Okay, so guys, if you still are unsure about the conversions, we'll do a lesson on that tomorrow. Okay, I'll just make sure that the notes are printed. And I have other stuff planned for today, so we'll do that tomorrow. Okay, so now we're going to do the exact same calculation just with these decimals now instead of those ones there at the top. So now we're going to say shaded area. And guys, it's also okay if you just write area. Okay, you don't have to write shaded area, it's fine. So shaded area is going to be the outer rectangle with the 0.22 times 0.11 minus the inner one, which is now those smaller values. If we do that. So, oh, and now they said we mustn't round off, which is a bit odd. So guys, I actually want you to write this whole value, which has a few decimals, 0.18768 meters squared. Okay, so if you didn't do that, if you did round it off, just write that quickly, the whole answer. They said in the instructions, do not round off your answers. Okay, that's a bit unrealistic. We will ask you to round off. So, okay, let's make sure that you have it in the whole. Okay, any questions? We are basically finishing off with area today. So I'm giving you guys some more questions to practice. And you're just going to be working for the rest of the lesson, and I'm going to be walking around and helping whoever needs help. Okay, we need to make sure that we all are on board with area. Tomorrow we're going to do conversions, and we're going to start with surface area and volume, right? Which is similar to area, but it's a bit more complicated. Okay, so the revision exercise. And then I'm actually going to give you some on the bottom, but I'll have to go first after you. Okay.
Yeah.
Oh, you have? Yes. Sorry, I forgot that it was from this exercise. Thank you. So it's actually just 3 and then 8 and 9. Thank you. Okay, I can put number 2 on the board for you to now. Make sure that you copy that down, please, if you write down what I want you to do. Grade 8, after that, copy that down. What I make when I say there is a bracket, use the pi button is because in the calculator they say for number 2, use 3,142 for pi. Alright, but remember I told you we don't do that here, we use the pi button on the calculator. Okay. I keep saying that in the book for some reason. Alright, I'm putting number 2 on the board for you. But guys, you need to start bringing your textbook to class, please. 3 and then 2 and 3. You can do 2 and 3 there. 3. Okay, guys. I think let me just check on this picture. Yeah, so it is a square, and now we know that. Okay. But then you get this that is a good question. They didn't tell us that all 4 sides are equal, but what they did do is basically that this is like a rectangle, right? So the has a 90-degree angle here, but then they're showing us that these 2 sides are equal. Right? But what do we know about a rectangle? Opposite sides will be equal. So this side is that one line, that one will also, right? And then these 2 will also have to be equal. Okay, so by this having that 2 two sides that are next to each other are just one, you actually tell you the all four of them on. Wait, that one. And what about the next? What are you going to do next? Two different sheets. But I'm going to also check. Next, these are kind of things. I'm going to do that. That's going to be another triangle. Okay. The next one, rectangle. That's this one. This one. I'm just going to triangle guys. So this is not. It's not really square, it's actually a rectangle. That's 4.31. That's 5.07. So this is also going to be 4.31. That's why this is the best case. So let's switch to I said next side, pull the two triangles out and put them next to each other. Right? We're going to have to do that here. So we have this rectangle here. And then we're going to take this triangle. Round up. Go around to the next one. We're going to take this triangle, that's top one, and this triangle, and I put them next to each other, right? And how are you going to get the base of this triangle? What are you going to do? The small base is 9.62, right? But the actual size of the rectangle is 4.31. So this base of your triangle is going to be 9.62 minus 4.31. If you have to put it together as one triangle, there's no way to know what that is and what that is separately. But if I put them together as one triangle, I can figure out what that whole base of the one triangle is. Okay. But it's actually two triangles, but I put it in together as one. And what's the perpendicular height here? Triangle 5.07. Okay. So this is a difficult one, guys. You have that rectangle there, but then this small triangle and that bigger triangle goes together for one triangle. And the area of that triangle is going to be half. Okay, whatever this is, times 5. Okay, tomorrow I'll do it to you guys on the other side of the picture. And yes, so that one, I have to actually want to tell you the back. I leave on page for now. I don't think we have enough information. Draw it for me. Okay, sorry guys, I don't think that I have enough information to actually calculate that. Here we can do, right? That's a circle. Thank goodness. What length is it give us there? 123, what's that? Okay, remember, in the area that's right. Hang on now. The next one, that's a triangle. Okay. So guys, it's actually this one that's the top one, right? So you can do this one, if not, don't move on. Do number 3 as well. Guys, I'm quickly going to go print a page from the answer series for you.